In topic 6.3, we're going to be talking about different types of fuels and what they can be used for. And these different types of fuels can be used for a variety of purposes. Some can be used for cooking, some can be used for heating, some can be used to power industrial processes, some can be used to generate electricity. So we'll talk about several different types of fuel. The first being what we sometimes call biomass or wood. So wood or biomass is used around the world for oftentimes heating of homes and also for cooking. And an example here, we see some folks collecting firewood to use in their homes for cooking or for heating. And here what we see is people producing charcoal, which is when you take wood and you burn it under low oxygen conditions to produce a more heat-dense material that we call charcoal. And oftentimes these are fuel sources that are easily accessible. Sometimes they're free, where you're just going out into the woods and collecting wood. They're often used in developing countries. So many times in developing countries, the primary source of fuel is firewood. Oftentimes in certain areas in the developing world, there's not access to gas lines to bring in natural gas or electricity, and so oftentimes firewood will be used. This can be harvested sustainably if you have sort of a forest in which there's downed wood, where firewood can be collected, it can be regenerated. You can sustainably grow forest and utilize some of that material for wood. So wood is one of the fuel types. Another type is something called peat, and this is probably one you may not be familiar with, but peat is basically partially decomposed organic matter, plant matter. And we can see here, this is peat. Here's where that peat has been dug out of. And peat forms when you have acidic conditions that are low oxygen. And the organic matter, as it decomposes, it forms this material we call peat. And really, peat is sort of the beginning stages of coal formation. It would have to be compacted and buried underground for long periods of time to actually turn into coal. But it's sort of the first stages. And this material can be harvested. It's been harvested for a long period of time. It's used for heating of homes and so forth. And we can see that most of the peatlands that are around throughout the world are in some of the most northern latitudes, areas of Canada, northern Europe, Scotland, Ireland, northern Europe, Asia as well. These are areas where this peat forms and can be dug out. Another type of fuel is coal, and coal is formed when you have organic material, plant matter, that over time is pressurized and under high heat as it's buried within the earth, and it transforms over time from that organic material into what we call coal. And we can see some of these different types of coal. So there's various categories of coal that have different heat content, different characteristics. So if we start in this diagram here, we have peat, which we just talked about, partially decayed plant matter that's found in acidic, low oxygen conditions. And peat can be used as a source of fuel, but it's relatively low in heat density. But if that same organic material is buried underground, over time, heat and pressure will transform it into coal. And the different stages of coal formation are shown here. The first stage is that lignite. So this is more dense in terms of heat content than peat. And you could see lignite is shown here. And it's relatively low in sulfur, which is something that's going to become important as we start to learn about air pollution and emissions. It has relatively low sulfur, but it's relatively limited. There's not a ton of this lignite coal available. Under increased heat and pressure, the moisture level in this material decreases and its heat density increases. And so what we have here is something called soft coal or bituminous coal. And this is used widely because it has a relatively high heat content. It's pretty widespread. There's a large supply of it, but it contains typically larger levels of sulfur, which get released when this bituminous coal is burned. We can see that here. And finally, the last stage here is hard coal, anthracite it's sometimes called. Under increasing heat and pressure, the density of the energy contained within this coal has increased. It's relatively low in sulfur, and it's probably the most highly desirable form of coal, but its supplies are relatively limited. Because it's dense in energy, it can release a lot of that energy when it is burned, and it's relatively low in moisture, and we could see the anthracite here. If you've ever been traveling on Route 81 near like Binghamton and you continue south through Pennsylvania, you'll see signs for an anthracite museum. And what this is, I think it's also called Steamtown. This is a museum dedicated to coal, and it is because this is coal country along those ridges where you travel through when you're driving on Route 81 through Pennsylvania. Coal has some advantages as an energy source. It's dense in energy. It's relatively plentiful in different parts of the world. It can be extracted oftentimes through surface mining, and it can be burned relatively without much processing, and oftentimes is relatively inexpensive. The disadvantages of coal as an energy source is it contains impurities like we talked about, like sulfur. It can also have mercury and lead and arsenic. And when the coal is burned, those materials are released into the air, into the atmosphere. Okay? And that can be an issue. The combustion of coal can lead to high levels of air pollutants. It also releases large amounts of carbon dioxide when it's burned. And that ash that's left behind after the coal has been burned, that can also contain some of these trace metals like mercury, lead, and arsenic. And so that material, that ash, has to be disposed of responsibly so that it doesn't cause pollution or impact human health as well. And there are ways of reducing some of these impacts. And we'll talk more about this when we get to air pollution, but there are pieces of equipment now that can help to remove some of those contaminants, some of those emissions that come about from burning coal. One example are scrubbers. Okay, this is a wet scrubber, and basically, if you have, the air that's coming out of the burning of coal comes through this wet scrubber, and as it rises, there are sprayers, okay, which basically mist that gas that's being released, and that mist clings to particles of sulfur and other materials that drips down, and that material is captured and can be disposed of rather than having it emitted into the atmosphere. And so that air that comes out, that's going to be released into the atmosphere through the stack, is cleaner than the air that was leaving the combustion of coal at step one. But this sludge contains all of those contaminants, like the heavy metals, like sulfur and so forth, and so that has to be disposed of. There are also ways of burning coal with limestone, and that limestone material will absorb some of those contaminants, and that reduces sulfur and reduces nitrogen oxides that would be released from the combustion of that coal. So that's called fluidized bed combustion. It's just another way of making the emissions less harmful. Natural gas is another type of fuel that's used widely. Natural gas is another one of the fossil fuels, and mostly what natural gas is composed of is methane. This is the cleanest of the fossil fuels when it's combusted. And natural gas is typically found in the same areas where you would find petroleum or petroleum products. And natural gas can be used in a variety of ways. It can be used to generate electricity. It's one of the main ways electricity in New York State is generated. It can be used in industrial processes. It can also be used to produce fertilizer, synthetic fertilizers. Many homes use natural gas for heating their homes or for cooking as well. And so this is a natural gas pipeline that you see here. It carries natural gas from one part of the country to another. Natural gas can be compressed and liquefied to make it easier to transport. Liquefied petroleum gas can be transported in trucks and train cars. Compressed natural gas is often what's moving through pipelines such as this from one place to another. And we can see here in this diagram on the right, this shows sort of where you find natural gas. And so what we have here is we see some natural gas that's accumulated here. It's less dense than the surrounding rock, and we can tap into that. We can drill down and extract that natural gas. Sometimes there's shale, which can hold natural gas in it, and through the process of hydrofracking, that can be extracted, as we see here. And also, we see that oftentimes natural gas sits on top of a deposit of petroleum, of oil. And so you could extract that at the same time that you extract the oil from that. The advantages of natural gas, as I said previously, are it contains fewer impurities. There's less of the heavy metals and nitrogen and sulfur. And so as natural gas is burned, it emits less sulfur dioxide and less particulate matter. It's about 60% of the carbon dioxide as coal. So burning coal produces much more carbon dioxide, leading to climate change. Disadvantages are that because natural gas is mostly methane, if there are leaks and it escapes in the atmosphere, it is a potent greenhouse gas. And so it leads to, it's much stronger in terms of climate change than CO2. Also, the exploration for natural gas through hydrofracking, which we'll talk more about later, can lead to contamination of groundwater and other issues as well. Crude oil is what we often call petroleum. It's a liquid that can be extracted from deposits, and then that crude oil has to be refined or processed into various petroleum products. Things like gasoline comes from crude oil. Plastics come from crude oil. Tar, diesel fuel, kerosene. These are all materials that are refined from crude oil, which is extracted from the ground. And that crude oil can be transported around the world or through various ways. There are some pipelines that can transport petroleum. And there's also huge supertanker ships which cross the ocean taking crude oil from one place to another. And this is an example. This is the tar sands. This is an area where you have this crude oil sort of mixed with sand and soil. And this is up in Canada, in Alberta, most of these large deposits. And it's very energy intensive to extract it, but there's large amounts of crude oil stored here. And so if you've ever heard about the debate regarding the Keystone pipeline, the Keystone XL pipeline, that's related to the transport of this crude oil from the oil sands in Alberta, Canada, down to the Gulf of Mexico, where it can then be shipped around the world. Oil has some advantages. It's relatively easy to transport because it's a liquid. It's dense in terms of energy. It burns cleaner than coal, but not as clean as natural gas. And has many applications. Many things such as plastics are made from petroleum products. Here what we see, this is an oil tank. An example is in my house. When we first moved in 1999, we had in our basement a huge oil tank like this, and our furnace that heats our house was powered by this oil tank. They'd have to come and fill it periodically. We got rid of that. We now have natural gas as our fuel source for our heat. Disadvantages: burning of oil, petroleum releases CO2. If it leaks when it's being transported, if there's an accident at an oil well or an oil tanker ship, it can spill large amounts of petroleum into ecosystems, which can have serious impacts on organisms that live in those areas. It also does have some contaminants such as sulfur, lead, mercury, arsenic, and when the petroleum is burned, those things get released into the atmosphere. So those fossil fuels that we've been talking about, they can be refined into different types of use. And one other concept that's a way of utilizing as much of the energy as possible is something called cogeneration. And so cogeneration is when the fuel source that's being used to produce electricity, but then the excess waste heat is also captured and used. So when a fuel is burned to produce electricity, it's transformed into heat energy, and that heat energy can be used to generate electricity. And if you can capture that excess heat generation using cogeneration, you can then use that to heat buildings in the nearby area. So what we see here on the top, if there's no cogeneration, right, about 40% of the fuel energy goes into making electricity, and 60% is lost as waste. But if cogeneration technology is used, you can capture about 92% of the energy from that fuel. Only about 8% is being lost. And so the more efficiently we use those fossil fuels, the better that is for the environment.